Of all the places in the solar system, why Mars? Because Mars is the least impossible option we have. It has a day that is 24 hours and 37 minutes long, almost identical to Earth's. It has seasons. It has polar ice caps. It has evidence of ancient rivers, ancient lakes, and ancient ocean. Once billions of years ago, Mars was warm and wet. It had a thicker atmosphere. It may have had the conditions for life. Something happened. The planet lost its magnetic field. The solar wind stripped its atmosphere. The water froze or escaped to space. Mars became what it is today, a frozen, irradiated, airless desert. But the bones of a habitable world are still there. The raw materials are still there. And we are a species that has always looked at impossible places and asked, what if we tried anyway? What we know about Mars. We have been studying Mars for decades. Orbiters. Landers. Rovers. We have mapped its surface in extraordinary detail. And what we have learned is both encouraging and sobering. The encouraging, water ice exists in abundance at and below the surface. Subsurface liquid water may exist beneath the southern polar ice cap. The soil contains minerals that could, with processing, support plant growth. The day length means humans could maintain something close to a normal circadian rhythm. The sobering, the radiation on Mars is 700 times higher than on Earth. Without a magnetic field, there is no protection. A human living on the Martian surface without shielding would receive a lethal dose of radiation within months. The atmospheric pressure is less than 1% of Earth's equivalent to being at 35 kilometers altitude on Earth. No human has ever survived at that altitude without a pressurized environment. Mars wants to kill you in at least 6 different ways simultaneously. Understanding how is step 1. Surviving it is something else entirely. What a Mars colony would actually look like. Forget the sci-fi cities on the surface. The first Mars colony will be nothing like that. It will be underground. Or inside pressurized habitats buried under meters of Martian soil, the only effective radiation shield available. It will be small. Cramped. Claustrophobic. The first colonists will spend most of their lives inside structures they cannot leave without a spacesuit. Every breath of air will be manufactured. Every drop of water extracted from ice and recycled. Every calorie of food grown in controlled environments under artificial light. Every component that fails must be repaired because a replacement is not coming for months or years. The psychological toll will be extraordinary. Imagine being permanently confined, permanently at risk, permanently separated from everything you have ever known, with the full knowledge that a single system's failure could kill everyone around you. The first Mars colonists will not be explorers in any romantic sense. They will be survival engineers. Every day a problem-solving exercise with lethal consequences for failure. The real threats to a Mars colony. The dangers are not hypothetical. They are specific, measurable, and in many cases not yet solved. Radiation is the most immediate threat. The 6-month journey to Mars exposes astronauts to radiation equivalent to several CT scans every single day. The surface provides no additional protection. Current shielding technology reduces but does not eliminate the risk. Long-term radiation exposure raises cancer risk dramatically, and the psychological effects of knowing this are themselves a danger. Then there is the communication delay. At maximum distance 401 million kilometers, a message from Mars takes 22 minutes to reach Earth. And 22 minutes to return. Any emergency on Mars, any system failure, any medical crisis, any catastrophic event must be solved by the people on Mars. Alone. In real time. With whatever they have. And then there are the dust storms. Global dust storms on Mars can reduce sunlight to near zero for months, catastrophic for any solar power system. They coat surfaces, clog filters, damage equipment. In 2018, a dust storm ended the Opportunity rover's mission after 15 years. For a human colony, a storm of that scale could be existential. Mars is not trying to kill you. It simply does not care whether you live or die. And that indifference is the most dangerous thing about it. What Mars could become. But here is the other side of the story. If we survive the first years, if we build the knowledge, the infrastructure, the technology to sustain a permanent human presence on Mars, something profound happens. Humanity becomes a 2-planet species. For the first time in our 4 billion-year history on Earth, human civilization would exist in two places simultaneously. A single catastrophe, asteroid impact, nuclear war, pandemic, climate collapse could no longer end the human story. The backup exists. The archive is running. The species continues regardless of what happens to the original. And over centuries, with the right technology, Mars could be transformed. Terraforming, the process of altering a planet's atmosphere, temperature, and surface to make it habitable, is not science fiction. It is engineering. Slow, generational, civilization-scale engineering. But theoretically possible. In 1,000 years, Mars with a thickened atmosphere, liquid water on its surface, and a sky turning from pink to blue is not an impossible dream. It is a very long project. One that might have to start with a very small group of very stubborn people in a very cramped habitat, refusing to give up. Here is the question that keeps philosophers and scientists awake at night. Should we go? Not can we, but should we? Is it ethical to send humans to a place that will almost certainly kill some of them, under conditions of extreme hardship, separated from everything they love, to serve a goal that most of humanity will never directly benefit from in their lifetimes? And here is the counter-question. Is it ethical not to go? Is it responsible, knowing what we know about asteroids, about climate, about nuclear weapons, about the 1,000 ways a single planet civilization can end, to remain here? To keep all of our eggs in one fragile, beautiful, irreplaceable basket? The first humans to set foot on Mars will face conditions no human has ever faced. They will be further from home than anyone has ever been. They will face dangers that have no precedent in human exploration. And they will go anyway. Because going anyway in the face of everything the universe throws at us is the most human thing there is. The question is not whether we colonize Mars. The question is whether we deserve to.